Hello everyone, my name is Vishali. I am assistant professor in CSE department at World College of Technology and Management, Gurgaon, Farooq Nagar. Today we are going to discuss the theory of computation, as you can see TOC. What do you mean by the theory of computation? Here the T stands for the theory, and when we come to the computation, computations means any machine that helps us to solve our day-to-day problem. It can be any kind of problem, from the small input problem or any high-edge language problem. So we are going to learn the basic principles and concepts, of the machine, or we can say the computation language. Okay. So, in theory of computation, we have the three main stages, or we can say the pillars of the computation. The very first pillar is the language. Then we have the automata and grammar. These are the three main pillars: language, automata and grammar. We also call them LAG. First, let's discuss the language. Language is the normal medium of communication. If I want to communicate with you all, then I need a language. Similarly, when we need to communicate with our machine or a computer, then we need a language. So, this language contains three main parts. First part is the symbol. Symbol defines the any form of symbol that we used in our day-to-day life. Like you can use normal small A, B, C, D, or we can use the capital A, B, C and so on, or you can also use the numerics, positive numbers 0, 1, 2 till as much as you wanted, infinite numbers. Okay, these are our symbols. Now the smallest unit of the language is also called the symbol. The smallest, why it is called the smallest unit? Because by using these symbols we form a language, just like our English language or any other local language. In English language, what we use small ABC and the capital ABC, and we form a sentence or a language throughout of it. Similarly, we use these symbols to form a language. That's why it is called the smallest unit. Then next we have the alphabets. Alphabets is always denoted with the sigma. In the theory of computation, we denote in the form of the sigma. What the alphabet contain? If I am giving the sentence, if I am giving a sentence, this is my class, this is my class, and in future also, in future reference also, I want to use these four alphabets only, then I will take this is my and this class as my future reference alphabets. That means in the sigma I will be writing it like this, comma is, comma my, comma class, so that in future when I have to communicate with my machine, I will be using these four symbols only, none other than these four symbols. So for a machine, if my symbols are A, B, C, then my alphabets will become, I need to form a language which are using these alphabet. Which alphabets? Small a, small b and small c. So for the entire communication we are using only these three alphabets, none other than. Next is the string. When we combine these alphabets, we are forming a string. Like if we have a problem like we want to communicate to our machine which can understand any language that starts with the alphabet A or alphabets B. We have a question, we want to make a string that starts with A. Then what are the different strings that can we form from these alphabets? What are the different strings that we can form? let's write it like this. First string can be that start with the A, and we have these three symbols over here. The very basic will be the A, B, C. Next A, B, B, C. Next triple A, and here we are making B and C as a null. We are making these B and C as a null, means we are not giving them as an input, we are only taking at A as an input, and A is also our starting symbol. Like this we can form any number of the strings we want. Okay, but if I define a length over it, if I define start with strings that start with the symbol A and having length 3, then how can we see what are the different strings that we can form from this alphabet? A, B, C, it is having the length 3, it is starting with the symbol A. Next A, B, C, 1, 2, 3, 4, we are increasing, so we can erase this. Double A, B, then triple A, and it is also starting with the symbol A. And like this we can form the finite set of strings. Finite means our language, basically our language is divided into two different types of strings. Your language can have finite and infinite number of strings. The finite number of strings say that we have the limit string where the limit is present. At that time we will say it's a finite. When we don't have a limit, we can go till the infinite set. We will after clearing the automata and what is grammar, then we will be coming into it. Okay, what are the finite and the infinite sets? Next is the, I guess language is clear. Next is the automata. Automata means any sort of machine which is using this language to give you an output. Automata is any sort of machine that is using this language which just we have discussed, using the symbols, using the alphabet, using the string. It is giving the input to the automata or your machine and generating a grammar out of it. So what is grammar? Grammar always uses the language. Grammar always uses the language. When we interact with each other, what we do? If I am interacting with you in English or in Hindi, then I have my own grammar, like where I have to use is, are, am. Like similarly, when we come to the machine is also having a grammar, like where you want to use your this is my class is our example. So this is my class. If I want to explain this to my machine, then I have to tell this, what is this, what is the mean by is, what is my and what is this class. Why machines always need a grammar? Because when machine take any input, they need to optimize it so that they can generate the result. So for the optimization, we need to optimize few words or few alphabets that are not needed or getting repeated again and again. So we optimize it so that our grammar can be smooth enough to work. So let's see one more thing. Let's generate a language. Let's take a question. Generate a language over the symbol A, B, where length of string should be 2. Okay, what are the various, as we can see, what are the I have written the we want to make a language over this A, B, and the length should be of 2. That means it's a finite. It's not infinite because the limit is there. So how can we write it? We have this, and what are the set of strings that we can generate from it? be like this. L is equals to set of strings is A, AB, BA and BB. Yes. So a language over A comma B means we can use only A and B, nothing other than A and B, where the length of the string should be 2, not above than 2. So the in every string you can see I have written only 2 words. 2 length of the string is 2, 1 2 1 2 1 2 and 1 2. So we are using AB, AA, AB, BA and BB. Now how the machine is getting generated, we have learned, we need to learn the principle and concept, and also about the computation, about the machine, how we are going to make the machine, not like on a large scale, how we are going to tell our machine that this is your language and you have to take the input of the language and you have to compute it accordingly. So these languages are very simple to accept for a machine, but when it's come to an infinite language, when these number of strings are infinite, like if I generate, I am just taking the above example only, if I have to generate a language some L over the A comma B, where the length of A is not a limit, okay, where the length of A is not given. So what will be the strings that we can generate, like AA, comma AB, comma BA, comma BB, and also triple A and some ABA and so on. Okay, for these symbols we can say it's an infinite language. How the machine is going to accept a infinite language. Now let's see about the various automata that we are going to discuss. First one is the finite automata. As we have said, we have the finite set of string, means your machine can take only the finite set, and the finite set of machine, when any machine takes an input, there are the various kind of machines. Like if we have a finite automata, then the finite automata is also distributed in 2 parts: finite automata with output and finite automata without any output. Here also we have Mealy and Murray machine. Here we have DFA, NFA and null NFA. See, any automata which accepts a finite set, we are going to discuss it in 2 parts. Finite automata which are giving to some output, we are going which give some output, and finite automata without any output. Without any output means we are going to construct it, we are just going to read their principles, how they form, how they are going to take the input, but they are not giving us any final like visual output of that. Their finite automata with output we can be discussed in the form of the Mealy and Murray machine, which we implement in our life. Let's discuss how we make a machine, how we make a small machine, how the machine takes the input and can generate an output. This will cover everything: generating the string, generating the language. Okay, so let's take this only, finite deterministic finite automata. Deterministic finite automata means we are taking the small set. Let's take an example. First take a we need a language for that. Means if I have to make any machine, then for communication I need a language. What sort of language I need? Like I am taking the same language which we had discussed earlier, like AA, BB, AB and BA, or let's take the smaller one. This is going to be broad. Okay, this is my language which takes which starts with the A and also terminates with the A. Okay, now how my machine is formed? This is the start symbol. Okay, even in the DFA or in any automata, whenever we start our machine, we start with the start symbol. How my start symbol always look like? It's a circle with an arrow associated with it. Then on seeing this, if I am writing the state, it's a state. We always write states. What are the states that we use in our machine? ठीक है, first I am taking the A as an initial state. On seeing this A, I am going to the another state, some B. This is a start state, this is going to be the intermediate state. Okay, and this is the transition. We are going from this to this. Whenever we give some input, what is going to do? Going to put on this state A, and then through this transition going to another state B. Okay, on seeing this A, I am going to the another state B. Now, as per our language, even a small a should be get accepted. That means your this state should be counted as a final state. When we write circle inside a circle, this is said to be the final state. This is our initial state and this is our final state. Final state is the state where the machine gets stopped or hold and said, yes, I have taken your input. It's like when you open your computer and want to open any text editor or something. Okay, I click it, then it means click. When you click, they will get command click, okay, and stop here and open your text editor. Okay, now when you write anything on it, start writing. Another machine, obviously that's the another machine, then it will start writing, and whenever you pause, the machine will get paused, or you will see nothing happening. When you stop writing on your keyboard, then this will got stop. Then next is A, means any occurrences of A. On seeing A, I am going to the another state B, then any number of A's if I am taking, then I will be accepting that. But what if something else will happen, like if a normal person comes and start giving the input B, he didn't know the language starts with the A and have to end with the A. He's a normal man and he didn't know how to write a machine. So what he can do? He can give us a B, input as a B, but we are not accepting it. We can't accept it. Our machine is not designed to accept this B. So this should be go into a dead state. Such state, this state is said to be a dead state. Dead state says if any input comes which is not accepted by your machine, then it should go to the dead state. It's like if I am writing in my notepad or the text editor and suddenly some other priority process came, another pop-up came out. Would you like it or not? No, we don't like it. I am writing something important and suddenly some another pop-out came which I don't want. So such state are said to be the dead state. We don't want that to happen. That's why for the smooth execution of the machine, whichever input I am giving, it should get accepted to the final state and not goes to the dead state. So the theory of computation basically helps us to give small machine, to give us small day-to-day life, from the day-to-day life to the high-edge machines. When we say how it is getting implemented, we have to see the principle of every machine. If I am saying I have a core I am working on the core i5 or the core i3, then we should concentrate on how this core i3 or core i5 is getting different, why the processors are fast, why the machine is getting so fast, what is the difference. The difference is how they are formed, right? So the basic principles of forming a small machine to a big machine, to the core i3, to the core i5, to the core i7, this is how they got built it. For now we have discussed what is automata, how we are using their principles to form a small machine like a DFA, right? We have seen this DFA, small DFA, which is accepting few strings. For more, if I say we need to understand the concept of the automata through the deterministic finite automata, what it is, how the grammars are formed using these, and they will really helpful in forming the small machines which will help in generating few inputs and also generating the output according to our requirement. The automata basically we use when we use the small robot or what, because it's a basic concept of how the things got formed, how your machine got formed. So when we want to make any broad machine using the concept, we use the same concept of the DNA and NFA, and also the Murray and the Millet machines, how they are getting implemented, what we don't have to implement, what we have to implement, and how grammars are getting introduced into it. So we will learn all this in future videos. Thank you so much for being the part of the video, and we will continue further. Thank you so much.